In this video, let's talk about another sorting algorithm which is called a quick sort. So the thing is, when you talk about sorting algorithms, the idea here is to explore different algorithms and we'll see how efficient it is. Now, when we talked about the other algorithms which we talked about till now, bubble sort, selection sort, they have a big O notation of n square, which we don't want, right? We want to make it faster or efficient. Now, in that case, we have to explore some other algorithms, and one of them is quick sort. Now, in the best case, the quick sort goes for n log n, which is much better compared to the n squared. But in the worst case, also it goes for n squared. So in the worst case, yes, it is almost there, but on average, it is n log n, or you can say the best case. So at least we are happy in the best case and in the average case. Now let's say, what is quick sort? So actually it uses multiple things. So let's talk about that first. The first thing is divide and conquer. So basically till this point when we talked about bubble sort or selection sort, we were doing the algorithm on the entire collection. So let's say if you have a list of values, which is 6 values. So what you do is you perform the operation of bubble sort and all the sorting techniques, which we have done before, applied on the entire list. But what quick sort says, let's do divide and conquer, which simply means divide your problem into multiple things and solve the problem or sub-problems individually. So what you're doing is you're dividing it, you're solving it, and at the end you will combine it. So that's your divide and conquer. So in this case, if you have 6 values, let's divide the values into multiple sub-problems and then sort it and then combine it. So that is your divide and conquer. Next, it uses something called a recursion. Of course, you can also use recursion in the other algorithms, but here it works with recursion. Now, basically, what is recursion? So when you call the same function by itself. So example, let's say the function name or the method name is show. And if you're calling show inside show, that's your recursion, right? And next, we have to understand the concept of pivot. Now, basically, pivot is something called a central point of a problem. Okay, so let's say you have this entire list here or the array. Now you have to find a pivot, and then based on that, you will perform the operation. Of course, it will make much more sense when we start, but remember, we have to work with the pivot. So those are the things we have to remember: divide, conquer, recursion, and pivot. There is one more thing, which is the tree. Now, basically, when you say you are dividing your entire list into subsections or sub-problems, what you're doing is you are creating a tree structure, okay? So once we start with the diagrams, it will make much more sense, but these are the things we have to remember. So let's see how your quick sort works, and then we'll try to convert that into algorithm, and then we'll see how to write a code for it. Now, the basic idea here is, let's say you have a list of values. So we are discussing about quick sort. So let's say we have a list of values. So let's go for 6 values here. And I will say this is 5, this is 3, 6, 1, 4, and 2. So let's say we have the 6 values. I'm not sure will it really make sense to use this example, but let's get started. Now with this 6 values, what you normally do is you do divide and conquer here. So the basic idea is break the entire list into sub-problems. Okay, something like this. Maybe we can create two different arrays. Here we'll be having 5, 3, 6. Here you can have 1, 4, 2, and then you can again divide this. Maybe you can have 1 and 4 here, and divide this into 2. Here also we can have 5, and then we can have another array which is 3 and 6. So we got these 2 arrays from the big array, and then you create the shorter format of it. So at the end, what you're doing is you're creating the small chunks. Now this is what your tree structure is. So we have divide, we talked about divide, so we are dividing it. We'll sort the array and then we'll combine it. And then since we are performing the sorting on each section, each sub-problem, that is your recursion. But is it the real thing? No. So basically we talked about the idea, but how do you divide the array? Randomly, I just divided the array, but that's not the main idea. But we have to divide, but not this way. So how we are going to divide this? That's the question. Let's remove this and let's go with the values here. The idea is you want to divide, for sure. You will divide this into 2 parts, but you need to find a point from where you will divide this. And that point is basically your pivot. Now, how do you find a pivot? Now, basically, the reason we get this partition or pivot to do the partitions of the array, right? Now, should we pick up 1? Now, that depends. So even before you divide, you have to do one more thing. So I'm saying pivot, but then that pivot should be a point which is at the right position. Let me repeat. The pivot is a point in this array which is at the right location. Now, if you see this, after this sorting, what the values you will get. So you will get values like, let's say, I will just write it in shorter format now. So you will get 1, 2, 3, 4, 5, 6. This is the output I want. Okay, just wait for the sequence of numbers here. But this is the output. So this is the output which we want from this input, which we have the bigger array here, or the big size which I mentioned. Okay, so if you talk about the value 1 here, so 1 should be at the first position, 2 should be at the second position, 3 on the third position, fourth position, fifth, and sixth, right? So they should be at that position. Now, since we have taken those values, and that's why it might be confusing, but you got the point, right? Doesn't matter what your values you have, it should be in the ascending order. So the first value, the smallest value should be first, and then a list goes on. Okay, now we have to make sure that at least you find one point from here, or one value which is at the right position. Example, if I say, let me take 4. Now 4, is it at the right position? The answer is no. 4 should be here, right? So instead of 1, it should be 4. Then we can say 4 is at the right position. Now, if you want to understand this with an example, so let's say you're in a classroom and then you have multiple students there, okay? And then you want to sort them based on their height. There's one way, as a trainer, I can be there and I can say, okay, you go there. And that's what we have done in the bubble sort, right? I was controlling it. But what if student can sort themselves? So they can compare each other and they say, okay, I should be here or I should be here, and they will move. Now, one way is one person can sort them, but then we don't want it. So what we want is, what if the students themselves can get into the right position? That will solve the problem, right? Okay, but how we are going to do here, how they will reach to our right position. Now what you do is, initially we don't know the position, right? So you can take any value. Normally we can find the pivot. So for the first iteration, what we are trying to do is, we want to make sure at least one value is at the right position so that we can divide the array. Now which value should we take? Technically, if you take the average value, or if you take the middle value, example, if you go from 1 to 6, the mid value is 3 or 4, right? So if I can take 3 as my pivot, it will be much easier for me to divide the array. So what will happen is, if I take 3 as my pivot, then 3 should be coming here, right? So this is the right position for 3, right? But it's not. If you start with the array, this is not at the right position. But if you get to the right position, we can divide into 2 parts, right? Okay, so that's the main idea. How will you get that there? So normally what you do is, if you can find a good pivot, and that's very difficult to find, because how do you know the mid value? Since we know the values here, I can find the mid value. But as a program or as a software, they don't have any idea what are those values are. So what we do is, we randomly pick the pivot. Maybe you can pick up the pivot, let's say 1 in between, somewhere, anywhere if you want. So you can pick up this 1, you can pick up this 6, or you can pick up the first value, or you can pick up the last value, or what you can do is, you can just add all these values and divide by 6, whatever value you will get. So try to find the average of it. That's what we can do. But again, that's a lengthy process. Normally, which I have seen, is they go for the last value, not the biggest value, last value, because we don't have any idea what the biggest value is. So we will go for the last value. Okay, so this becomes your pivot. That means we need multiple variables here. Now what variables we need? So I will just write variables here. So the first variable we need is a pivot variable. So we'll say pi. Okay, and then you need few more variables. You need a variable I for the positioning. Again, we'll discuss what this positioning is. Then we'll need a j, which will go through each element, and we have done that in the sorting, right? So when you jump from each value, that will be done by j. And then of course we also need array here. So let's say this is ARR, this is your array, okay? And let's have the index value. So we'll say this is 0, 1, 2, 3, 4, 5. Those are the index values we have. Apart from this, we also need a low and a high variable. Okay, so we'll say L and H. So let's say this is L and this is H. Now, normally we can say H is the last value, or we can say it's a length minus 1. So we can say that. So we have a low and we have a high. So low starts from the first, and H is the last value. Now, how do you perform the operation? It's very simple. First, you find the pivot. Now we know that we are going for pivot, which is 2 in this case. So what you will do is, let's take this 2 as the pivot. So I will say this is P. So this is referring this 2. So Pi variable at this point is referring to. So I will say this is 2 in this case. And then we need 2 variables. So let's take variable I. Now by default, the value for I will be the lowest value minus 1. So let's say the I value is here at this point. You know what I will do? Let me just remove this portion at this point, because let's keep the slate clean. So we need an I variable and then we need a j variable. So j will be here to start with. So I will be here at the -1 position, j will be here at the 0th position. And then what you do is you basically run a loop where of course the I will also increment, but the main loop here we want is for j, okay? So we'll take a for loop for j. Okay, so let me write the code here. So what we want is, of course, the rough code. So I will say for j will be starting with low. Okay, that's what we are doing here. And then j should go till n, but then we are not using n variable, right? We are using variable high. So let's say j less than high and j plus plus. Now what you are going to do inside this loop? So basically, you will first make sure that you get the pivot value, right? So you will, of course, you have a pivot value here, which is 2. And then you also got I is still -1. Now inside this loop, what you will do is you will check if the ARR, which is in this case, we have an array, if ARR of j, if it is less than the pivot, so pivot, we have a variable here. If it is less than pivot, you will perform some operation. Now, if you compare the values here, do you think the ARR of j, which is 5 in this case, is it less than the pivot? Because pivot value is 2. No, it is not less than pivot. So we'll not do anything. But we have to find a value which is less than 2, right? So if the value phi is less than 2, you will perform some operation. Since it is not true, we are not going to perform any operation here. So basically, you're going to shift your j here. Okay. Now, why we are doing it? Of course, we are running a loop, right? So j starts with low and then we have to increment. So j goes there. It will compare itself with the pivot. Is it small? No. So again, you will shift your j. Then you compare 6 with 2. Then is it smaller? No. Then you shift your j here. Then you check. Is it smaller? Yes. What if it is smaller? Then what you will do? In this case, if it is smaller, you perform some operation. First thing you do is you increment the value of I. Basically what you're doing is you are shifting your I here. Okay, that's done. Next, we have to make sure that you swap the value of I and j. Okay, so whatever value you have with I and j, you basically swap them. So what I'm saying is, take this value here, move this value 5 here, and move this 1 here. Okay, now how do we do that? Of course, we have used it before. So we can use a temp variable, or maybe at this point I will simply say swap and then we'll write the logic later. So I want to swap basically the value of ARR of I with ARR of j. Okay, so we need to do the swapping. That's it. These are the things we are doing inside the if condition. Now, once that is done, of course, you have to move your j again because we are in a loop. So j will go here. Now, again, you will compare. If the 4 is less than 2, no. And that's it. J will move here because if it is not less, then we are not doing any operation. Then your j goes to the last value because your j ends at high, right? So j reaches here. And of course, the pi and j is same. Then you don't have to, of course it is false. This condition will be false, which is ARR of j is not less than pivot. So in this case, it will not swap. But what happens after that? Even if you complete the entire loop, do you think 2 is at the right position? No, 2 should be here, right? So this 3 need to go there. So what you do is you perform one more operation after the loop. So after the loop, what you will do is you will basically swap the ARR of I plus 1 with the ARR of high. Okay, now this is the operation you have to perform. Now, what will be happening here? So what is the value of I? Value of I is 0, which is index. You're picking the next value, which is 3. So you have to swap this 3 with this 2 because that's what your ARR of high is. So you will move here and you will move this side. Now, by doing this, we made sure that the pivot value which you choose is at the right position. Can you confirm, is it the right position? Yes, it's at the right position. Now what you do is you divide, if you observe the array, if you look at the pi, which is pivot here, now if you see the left hand side of it, this is always lower than 2 and this value is always greater than the 2. So yes, 2 is the right position. Now what's the next step? The next step is very simple. You divide this array based on the pivot value. So what you do is you create another array here. And in this, you will be having only one value, which is coming from here, right? In fact, we can also draw an arrow there. So this is coming here. 2 will remain there itself. Maybe I can write 2 here. We don't have to work with 2 because it's already sorted. And then you take this particular section into another array. not another array, but let's say logical partition we are doing here. So we'll get another array here. So we are doing divide and conquer. So here you're going to have 6, 5, 4, 3. If you observe, they're not sorted, but at least we got the partition, right? Now what you do is you again perform the same operation which we have done here in the first example. Now you help me. Should we start with this? Yes, we can start, but don't you think we only have one value? And whenever you have one value, it is already sorted. Let's work with this. So what you do is you again take the same thing. So you take the low, you take the high, and then you of course you again have this p all these values here. So all these variables are still exist because you are going to apply quicksort again on this particular values. So let's get started. Let's take pivot. Which pivot we are choosing? Of course, we are choosing always the last value. So this is your pi pivot. Then you got I here, you got j here. Then what you do is you start running your algorithm, which is first you compare the value of j, which is 6 in this case. Is 6 smaller than 3? Look at the algorithm which we have done. Is 6 smaller than the pivot? The answer is no. So you will simply move your j here. Again, check, is it small? No. Shift, is it small? No. Is it, then again goes here, is it small? No. Then what you do is you have not done any swapping, but at the end we got one more logic, right? So once you complete this for loop, you will do something with this, which is swapping the I plus 1. So I is at -1. So you have to basically swap the 6 with the array of high, which is 3. So this goes here and this goes here. Now if you look at the pivot, this is sorted, right? So now what you do is you write 3 here, which is your pivot value, and then you divide your array into 2 parts. But since the pivot was the first value, what you will do is you will get the new array now from this, which is 5, 4, 6, and then you start performing operation here. Now what operation? The same operation which we have done. Again, you will apply quicksort. So this is L, this is H. So PI is referring 6 here. And then you start. So you got I here, you got J. Then you start comparing. Is the first value, the value of J, is it smaller than the pivot? Yes. Now when you say yes, what you will simply do is you will increment the value of I first. If you look at the code, that's what the logic we have. And then you swap the value of I and J. Now in this case, I and J are referring to the same value. So swapping doesn't make sense. Of course, they will get the same value. Then you increment the value of J. J goes here. Check, is 4 less than 6? Yes. In that case, you will move I here. And then you will swap the value of I and J. Again, it remains same. So nothing to do here. Then you shift your J here. Of course, the array of J is not less than pivot because they're the same value. Then this loop's end, the for loop ends. Then you perform this operation, which is ARR, which is +1. This will be replaced by high, and that remains same, right? So there's no swapping. I know it all depends upon the value, type of values you're getting. So at this point, there's no swapping happened. So this remain as it is, 6. But then you will get a new array here, which only has 5 and 4. And then you start applying the same operation. Let's get started. In fact, I will just write this bit up so that I will have some space. And this is coming from this particular section. Then what you do is you will take the same value, you say, and if you observe, we are doing recursion, right? The same steps we are repeating multiple times. So LH, we got PI here, we got the variable I referring to -1 position, or in fact, not -1 position. It is 1 less than the low. So in this case, the low is this position, right? Now, what is this position? This is, in fact, we should have maintained the index value, right? So this is 0, this is 1, this is 2, 3, 4, 5. Then we got 3 here, which is this one. This is 3, 4, 5. What we got here is 3, 4. So these are the index values for them. Okay, so we got I referring to the index value 2 and J is here. Then what you do is you simply compare the same steps which we have done. So the array of J, is it less than 4? No. So all this operation, this swapping is not needed. You will simply move your J here. Again, do we need to swap? Of course not, because the array of J is not less than pivot, so it will remain same. But then you will perform the last operation, which is this one. What it says swap this value with the high value. So this will be swapped. So 5 goes here, this goes here, and this goes here. Now, if you observe, we divided and we conquered. So if you merge this In fact, we are not merging physically, we are merging logically, right? Because nowhere we were breaking the array. But if you try to merge logically, what you will get? So you will get this 1 first, which is 1 goes here, then 2 goes here, then by sequence 3 goes here, then by sequence this 4, 5 goes here, and then this 6 goes at the end. So if I'm to write this will go here. So let me write 1, then this goes here, that's 2, then 3 goes here, that's 3. Then if you can see in the binary tree, we always goes from the left to right. So if you see the left, because 6 is there on the right hand side, you will say 4 and 5, and at the end you will get 6. Now this is sorted. So after all this explanation, this is how basically you sort them. Now this logic which we have written here is actually a part of a partition method. So this is a partition method. So the entire thing goes there. But we also need to return the pivot value, right? So which is the pivot value? So we'll say return I plus 1 because that's what the pivot is. But this particular function will be called by whom? So we have a concept of quicksort here. So quicksort is going to call this partition. How? That we're going to say in the code itself. So you got the idea. Basically you divide, sort each values, and you will get the output. Now this will make much more sense once we start coding, and I hope it will get clear.